To start, we are going to open the Opus software, double click on Opus 7.8. The password is OPUS, all capital letters, and ensure the workspace is this EasyView workspace. Click Login. The software will open up and it will give you a dialog about some information about the software. Just click on OK. And now to start a macro ATR measurement, we are going to click on this button in the top left that says Routine Measurement. Once this dialog opens up, the two tabs you want to interact with are the Basic and Advanced tabs. In the Basic tab, first of all, ensure that the macroatr.xpm file is loaded. If it is not loaded here, click on Load, find it in the list, and then click Open. Here you can put in some information. In particular, you can put in the sample description. This would be a sample ID for your first sample that you're going to measure. And you can see that this information comes through to the file name. In the Advanced tab, you can set the file path where you're going to save your data. Click on the three dots here and set your file path. You can change some settings here as well. Your resolution, the sample and background scan times, the type of spectrum that you are going to save, and the blocks that are going to get saved into the file. If you're not sure about any of these settings, leave these as default, and they will cover most of what you need. Going back to the Basic tab, now what we are going to do is run a background measurement and then the sample measurement. So first of all, we're going to prepare to run the background measurement. In preparation to do our macro ATR measurement, we first of all need to ensure we have a clean crystal so that we get an accurate background measurement. So I'm going to move the pressure head away from the crystal. And now I'm going to take a Kim wipe and a small amount of isopropanol. And we're going to gently wipe the surface of the crystal, ensuring that everything comes off clean. And then I can also just gently wipe underneath the anvil of the pressure head to ensure that that is also clean from any residues from a previous sample. And now I can move the pressure head back into position. Just a reminder, do not apply the anvil to the crystal during the background measurement, and do not apply the anvil to the crystal without a sample in place, as this can cause damage to the crystal. With the crystal now clean, we can run the background measurement. Click on Background Single Channel. We won't see any spectra being acquired, but we will see down here in the software where it indicates that the background measurement is running and the number of scans that are being acquired. This will count up to the number of scans set in this value here. So in our case, it's going to count up to 32. With the background scan now completed, we can prepare to collect the sample acquisition. We're going to click on Sample Single Channel. And here we can now see a flat baseline, which is effectively the background minus the background. And we're now going to apply pressure to our sample to get the measurement. I can now place the sample onto the crystal. We want to ensure that it covers the diamond crystal section. That's the clear square part in the middle of the sample plate. And now I'm going to apply pressure using the pressure head. So we bring down this lever, which pushes the anvil down towards the sample and applies pressure against the sample so that it squashes onto the ATR crystal. And then we lock that in place by pushing that all the way down. You'll notice that the pressure indicator here has a red dot in the middle of the circle. This is indicating optimal pressure. If when you apply pressure using the anvil, the red dot is at the lower end of the circle, this indicates low pressure between the anvil and the sample on the crystal, in which case we need to lower the entire pressure head down to increase this pressure. So release the anvil from your sample, turn the collar at the back to bring this down towards the sample, just about a quarter of a turn, and then reapply pressure again and see how that impacts the red dot. You want to bring this into the center of the indicator, so I need to increase this a little further. So I go another quarter to a half a turn and then squeeze down again. And now a red dot is in the middle of that circle, indicating optimal pressure. If the red dot is at the top of the circle, this is indicating too much pressure is being applied. So release the anvil from the crystal, increase the height of the pressure head, and reapply pressure again to bring that circle back into the center of the indicator. When we apply pressure using the pressure head, we will see that the spectrum suddenly appears once we get pressure applied. So now the polymer is being pressed against the crystal and we are getting the ATR signal coming through. Here is where you can adjust the pressure of the pressure head as well, monitoring the signal that you get back. Once you're satisfied you're getting an appropriate spectrum, now click the Start Measurement button. And once again, we won't see the live spectra being acquired, but in the bottom of the software, we see the acquisition proceeding. With the acquisition finished, we now get our data presented to us in the browser, and we can see part of the spectrum here, but we can't see everything. What we are going to do is click on the Scale button in the toolbar to scale the spectrum to the full screen. And here we can see our acquired ATR spectrum. With the measurement complete, you can now release pressure with the lever, remove your sample from the plate. Sometimes the sample will stick to the top of the anvil. Remove the sample from the plate, and once again, clean the crystal and the anvil with isopropanol, just to ensure you minimize cross-contamination. Move the pressure head out of the way. Just give the crystal a gentle wipe with IPA and also the bottom of the anvil as well. Bring the pressure head back into the center position and you're now ready to repeat the process again. If you want to change the color of the spectrum, come over to the browser, right-click on this first block and go to Change Color. And here you can select different colors from the menu. I'm going to click black. Some basic processing that you might wish to do in your spectrum might include peak picking. Click here on this peak picking button, click interactive mode. And now to get rid of this cursor, right click and then left click on this button, which changes the peaks that get picked in the algorithm. You can see that as I bring this line below those peaks now get picked and labeled. If you still don't have all of the peaks in the spectrum that you want identified, you can control that with the threshold slider on the left, where by lowering the threshold slider, less peaks are picked, and by increasing the threshold slider, more peaks are picked. You don't want to go so far as to pick everything in the noise, like this example. You want to bring it down until you're getting just the peaks that are relevant to your spectrum. This requires a bit of an assessment on your part to decide what is appropriate. Once you're happy with your peak picking thresholds, you can click Store, and these peaks are now saved onto your spectrum file. You may wish to also try to identify the material based on this spectrum, in which case you can go to Spectrum Search. We are going to search based on the file limits, which is the entire spectrum. But if you wish to only search on a partial part of the spectrum, you can deselect file limits and change how much of the spectrum is going to be searched. Click on Search Library. It will then look at your spectrum and try to match it against a database of similar spectra. If you wish to maximize your red spectrum here, this is your measured spectrum against the database spectrum here in blue in this case, you can come up to the view menu up here and click on maximize all so that you get better alignment between your spectrum and the database spectrum. And here we can now scroll and cycle through the different example spectra to see how things align. This list is sorted by hit quality. So the algorithm is assigning the first one in the list to be what it believes to be the best assessment match. You may wish to save your data out as a text file, in which case ensure that this block in your data file is outlined in red. Go to the File menu and click on Save File As. In the Mode tab, ensure that we have data point table selected. Come back to Select File, and we're going to ensure that you have the correct file path. So click Change File Path, go to your folder, click on OK, and this is the file name that's going to be selected. You can change this if you wish. DPT is effectively a comma-separated values format, a CSV type text format. So you can click on Save, and that will now write a text file for you. If I come to FTIR data, go to my file. If I look at this file, for example, here, and we open it up in Notepad, you can see it is simply comma-separated values. So this can be imported into any plotting software to allow you to manipulate the data. You might also wish to just simply save this in a Word document for reporting functions. What you can do in this case is just right-click on the spectrum and select Copy All. Open up a Word document. Select a blank document. You can change the orientation, and otherwise simply press Ctrl-V and you'll get a screenshot of your spectrum with the file name, sample name, and your peaks labeled on the spectrum as well. This can then be simply saved out as a Word document. If you have multiple spectra displayed at once, you can control how they are displayed using these controls in the toolbar. You may wish to maximize all of them, in which case it will find the maximum peak on each spectrum and change the y-axis for each spectrum accordingly. Otherwise, you may wish to offset them, and you can use the stack function where you have two separate plots of each of the individual spectra. Or alternatively, you can keep them on the same plot and adjust the positions of them. You can squash the spectrum by going to Shift Curve Top, and this allows you to grab the top of the spectrum and compress it downwards. And if you click on each individual spectrum, you can do this. You can then shift an entire curve with this Shift Curve Hole button, And so now I can grab and slide an entire curve upwards. If I click Shift Curve Bottom, it will keep the top at this position and simply adjust the bottom of the spectrum so that I can optimize the positioning of each of these spectra. And then you can save this out or copy this out as before.